Welcome back, everyone. First, announcements. I just want to be sure that you remember you have assignments. You should be working on them this week. You have work to do. Please do not forget your assignments. Submit on time. Now, moving forward, one of the assignments that you are doing is with programming. We're moving to that part. So I want to talk about principles of object-oriented. First, about design concepts, and then about programming with object-oriented languages. So as usual, if you can turn on your cameras, please. Let's see. Principles of object-oriented, things that you should try to do in your programs. It doesn't matter what you are doing, what problem you are solving, but when you move from the requirements to programming, to the design, your class diagram, when you do that jump, things that you should try to apply when possible: abstraction, encapsulation, relationships, polymorphic behavior, concurrency, and persistency. Those ideas is basically how do you solve a problem with object-oriented programming. You do this just because you are using an object-oriented programming language. The key concept here are things that you already know how to program because your previous experience from 110 to 360. I just want to be sure that we understand the concepts and what we should do. Number one, talking about abstraction. Definition for your exam. What is abstraction? What is the meaning of abstraction? What we did for the Pac-Man video game is an abstraction. Our class, each of our classes is an abstraction of something. It's a representation of the minimum essential elements in that something. For instance, for the Pac-Man, the minimum attributes, the minimum elements that represent the Pac-Man are these coordinates, X and Y. The only thing that we need to represent Pac-Man for the computer is two numbers that represent the position of the element in the system. Something that you should be careful. What do you think about adding here an attribute color for the Pac-Man? Could be good, bad. Why? Could you add an attribute color for the class Pac-Man? It could be a good idea. Why yes, why not? Anyone in the chat? Color for the Pac-Man, a new variable. Let's think. We already have the Pac-Man in yellow. This program, you already have it. I share the code with you. Do we need a variable color in order to draw the Pac-Man in yellow? What could be the goal for adding a variable color in the class? Do we need a variable color for the ghost? What could be the goal of adding the variable color to the ghost? That is a very good point. The Pac-Man is always yellow. Do we need a variable to store yellow? That is going to be always the color, at least for the particular game. Two options. Number one, you do not need a variable color for the Pac-Man. Option number one is this class. Option number one is, you know what? In my abstraction of Pac-Man, in my definition of the essential features for the Pac-Man, I think I do not need color because that guy is always going to be the same color. Now, just to clarify, just in case that someone do not know what is the color of the Pac-Man, you can define here not a variable, but a constant. You can define there color, but if you define color, your abstraction should be, you know what? This color is final, a constant in Java. Moreover, that color probably also is going to be static because all the Pac-Mans, all the objects Pac-Man are all of them the same color. Moreover, that one is going to be a constant with a value, and the value is going to be defined from the beginning. If you want to add the color, this should be the correct way to do it. This should be the representation of what you are sharing with me in the chat. Always the same is a constant. I want you to the people to have the knowledge that the Pac-Man is yellow, for instance, or no variable at all, assuming that everyone knows that the Pac-Man is yellow. What is essential? That are the decisions that you are taking when you are doing the class. When you do programming, when you create a class diagram, it's not only about showing that you know how to do the programming. In every step, from the names to the variables, to the data type, to whether or not the variables exist, you take a decision, a design decision. Well, we need to review details. Anyway, abstraction of the Pac-Man. What about the ghost? Should the ghost have a variable color, a variable or a constant? Answering the question in the chat, in particular, when we have a constant, the constant is going to be final, but usually also static because it's going to be constant for all the objects in the class. When you have something static in the class diagram, that something is going to be underlined. When you read the name of a method or the name of a variable and you have that with a line below, that is static. And that is going to happen with your constant variables, those that are static, and also with the main method. It's going to be with the underline. So the ghost, what about the ghost? The essential or minimum representation of the ghost in the game need a variable color because we have the X and Y also. What about colors for the ghost? Constant, variable, or nothing? Variables. Could you agree that for the ghost, we need a variable? And the main reason because we could need a variable is, well, we're going to use that class. Maybe we're going to create 4 objects, but for each object, for each of the different ghosts, probably we want to define a different color. In the classes that I shared with you, in the Pac-Man that we did, we only have one ghost, the red one, so no variable color. But if I want to create 4, each in a different color, that is a consideration that, well, you need color. It's not going to be static. It's not going to be final. It's going to be a variable. And you need to pass the value in the constructor. Moreover, the color change when the hunter situation. So you're going to have a set color and probably you're going to set the color in blue in those circumstances. That is another thing. That is true. Now, for that situation in particular, you can assume that all the ghosts go blue when they are in that situation. You like the Pac-Man is yellow, but when you create the object, each object have a color, and that means a new attribute. Again, abstraction, the essential elements that you need to work with the class. The maze, the ghost, the game, all the classes that we create for our Pac-Man game, the classes that you are doing for your assignment, think about this. For every single class, only the essential elements. And we're talking about attributes, but also methods. I am going to show you examples. This is abstraction. The next one, encapsulation. And the question for you in the exam is, what is the difference between abstraction and encapsulation? Abstraction. What is observable? What is the meaning of this for your classes? The minimum thing, the minimum elements that are observable. Which elements are observable in your classes? Professor, but you were talking about the variables. The variables have a getters and setters. Anything that you have with a getter and setter to access a variable, you consider those variables and your public methods and the things that you're going to be able to observe in your class, the things that the exterior know about your classes. The variables position, X and Y, they are private, but we have methods that allow us to know that those two variables exist. All this, as we reviewed before, up, down, left, right, those guys are getters and setters for the X and Y position. The X and Y is part of the things that the world know that the Pac-Man has. The draw, something that we do with the Pac-Man, draw the Pac-Man, our method draw that is public, is part of the things that the world know about it. Encapsulation, the code, the things that are hiding inside. When you think about encapsulation, you need to think about the things that are private, the things that the exterior world is not going to know about the class, but are going to be there. This is the exterior of my class ghost. For my class ghost, something that you know that the class has is a draw. Something that you know that the class has are those variables, X and Y. I am not showing you here the method for accessing the variables, but you know that they are there. There are more. Do I have, or should I have, for instance, private methods for the ghost? Not the one that we did in the class, but the one in the real game. Can you think that there are methods inside that are going to be probable, private, that the people do not need to know that those methods exist, however, they are working there? Any example about it? Any method that is encapsulated in this particular class? Hopefully you agree with me. Several methods are going to be involved if you want to calculate the movement of the ghost according with the real Pac-Man video game. Do you remember that we review how they should move just to create examples of activity diagrams, just to create examples of if-else conditions? I am sure that you can notice that if you want to translate those rules, the movement of the ghost, to our piece of software, the one that we reviewed before, each of those rules, the rules to move Pinky or Blinky or the other guy, each of those rules become at least one method or a collection of methods. Some of them are really elaborated. Those methods can be encapsulated because those methods can be private. They do not need to be public. The only method that needs to be public is draw. Ghost, I need you to be on the maze. I need you to be draw in your next position. What is your next position? There are some methods there that are going to help you to calculate your next position. Those methods follow a particular algorithm, a particular set of rules. No one is going to use those methods directly. Only the method draw is going to ask for help to those methods, helper methods. They can be private. They are encapsulated. When you define a class, you need to think about what part is public, what part is private, what is my abstraction, the important elements, and what information or what actions I want to hide from the exterior, what I am going to be encapsulating. Two things. Looks like very simple. Looks like every single decision could be correct. It is not the case, and we're going to review things later. But well, for now, encapsulation, the public thing, encapsulation, the private things, the ones that are inside, abstraction, what the outside is looking at in a particular class, encapsulation versus abstraction. Now, the picture from the book. Once you have your classes with public and private parts, the next action is to connect them, something that we already reviewed with our class diagrams. You connect your classes with those three relationships. There is no other thing. Help me. What is the name in the UML class diagram for using or use? What is the relationship in the class diagram for using, association? And what is the meaning in the source code? What do you put in the source code? Calling a method. Calling a method. If you need an object to call the method, that is a different story, but calling a method using. Having or has, which are the two relationships in the UML diagram that correspond to this guy? Two. Composition aggregation, the one with the diamonds, the meaning in the source code. What do you do in the source code in order to represent an association or an aggregation or composition? Not yet implement or extend. Global variables. And obviously for is, this one is inheritance. And therefore you have realization, generalization, or specialization, and is implements or extends in Java. Good. So my classes, encapsulation, abstraction, relationships. You already know the relationships. This is easy. Now, the next one, number 4. That one is probably the most important principle in object-oriented polymorphism. Can you help me to explain this? What is the definition? What is polymorphism in object-oriented programming? You need method override, yes. You need a parent. Let me put the elements. Number 1, always, in order to have polymorphism, you need a family of classes. A family. You need a parent, and you need child. In order to use or in order to work with polymorphism, whatever that is, always is going to be involved a family with a parent and one or more childs. The concept of polymorphic behavior. Polymorphic behavior is the parent can be replaced by any of its childs. For instance, you can have a variable parent. This variable is from this class, the parent. But you can make that one equal to parent. And that is obviously correct. It's a variable equal to an object of that class. But also, you can make that one equal to the child one. You can have a variable, the type of the variable is the parent. But that variable can handle an object, obviously from the same class, but also for any of the classes below. The head of the family can be equal to any of the members of the family. And that is a very powerful thing. We use this in our Pac-Man. If you remember, we have this ghost and the Pac-Man and even the power pill. And what we did is to put a common parent to all of them. Bravo. What we did is to create this family. And we define the parent. And we have the child. The power of this is for the maze. The only thing that we did is to create an array of drawables. And that array was a polymorphic array because we create an array in our example with 3 elements. And in one array that, according with the rule, should have 3 elements from the same type, we have in that array 1 Pac-Man, 1 ghost, 1 power pill. Our array was from the parent class, and we can use the childs to replace the parent in any of the positions. Moreover, what happens when we ask the parent to be drawn in our example? What happens when we have variables and these variables are the parent? And obviously the parent have a method draw and the childs have also that method. Do you remember we have an array of drawables in maze? And inside of the paint component, we call draw for the Pac-Man and we call draw for the ghost and we call draw for the power pill. Which method draw was executed? The method draw that corresponds to the type of the variable, parent, drawable, or the method draw that corresponds to the object that we put inside of that variable. Hopefully you remember your variable, the type, is the parent. But the priority, when you run a method, is the child. If you create a variable drawable, but you store an object Pac-Man, and you call draw, the draw is going to be the draw of the Pac-Man. If your variable is drawable and you create a ghost, you call draw, the draw is going to be the draw of the ghost, and so on. The variable is the parent. You can put inside whatever you want. And when you call for an action, the action that is going to be executed is the action in the childs, not the action in the data type of the variable. And that is polymorphic behavior. That is, as you mentioned in the chat, choosing the data type, not in compilation time, but runtime. When you are running the program, whatever is your object, any of the childs. The only limitation here is you need a family. You need these 3 connected to a common parent. But when you have the family, when you have the parent, you can start working with the polymorphic thing. This is the most powerful thing that you have in object-oriented. We're going to be using this a lot. Just like when we did the Pac-Man, and the first thing that we do, we have our classes, and we need to find if, by any chance, we can create a family in any of these places. Any of these classes can be connected with inheritance. Can we create a new parent or a new child from any of these classes? Those are questions that you need to ask when you are defining your classes. Now, why this is important? Inheritance, association composition, which of these three, A, B, or C, should be a relationship that you could try to avoid? That is better, do not use. I mean, you can use all of them. Which one is not the first one that you could choose? Be correct. Remember, diamonds imply a very strong relationship. If we can avoid that one, it's a good idea. Now, which one is the best one? The one that establishes a connection that is not strong. Calling methods is the best relationship that you can have between classes. Use calling methods, use association. This one is in the middle. It's not like the best one, but it's not something that you should avoid. This one is in the middle because calling methods is a very nice thing to do after calling methods. When you need something else that use calling methods, this is your choice. And that one not just because you need a parent and a child. One of the most important reasons to use that one is because you want polymorphic behaviors. It's because you are thinking about something here can work better with polymorphism. Just like, again, we did with the Pac-Man, the ghost, and the pill. You remember the principles. We are going to do examples in the source code. First association, then inheritance with polymorphism, and the last option, composition or aggregation. Anyway, polymorphic behavior. Last one. Something that you are going to need to do in your programs is concurrency. Good news, our computers can do more than one thing at the same time. Bad news, we need to know how to program that. Help me, how do you program in Java one program doing more than one thing at the same time, quotation mark? For instance, what did you do in order to have the Pac-Man video game allowing you to move the Pac-Man with the keyboard and also the ghost moving randomly without your intervention? Two things what happened at the same time. The Pac-Man and the ghost were moving, different inputs, but they were moving. They were happening concurrently. What do we do in programming to achieve concurrency? Threads. Threads. The concept is concurrency. The concept is more than one thing happening at the same time, quotation marks at the same time. The implementation of that in programming, multi-threading, multiple threads, threads. Now, in Java, what do we need? What options do we have to work with multiple threads? What I do as a programmer to create more than one thread in a program in Java? Join is a method in which class? Yes. You have three options in Java in order to ask your programs to do more than one thing. You use one of these by default in the Pacman. Again, I add you to do things with the Pacman that later we're going to need. But you have three options to create multiple threads in a program in Java. Option number one, there is a class thread. We're going to work with that class. Option number two, we have an interface runnable. And those two can work together. The class thread alone, the class thread with the interface runnable, option one, option two. Option three, the easy one, not the bad one, but a really easy one, a timer. A timer is a thread, a particular thread that is going to be doing something every period of time. That is what we did with the ghost. We want concurrency in a program. Those are our options. You already use one. We need to use the others. Do more than one thing at the same time. Concurrency. The last one, persistency. Persistency. Make an object exist beyond the life of the program. Store information. You can run your program here. You are going to create objects, and all the objects are going to die when the program finishes, if you turn on the computer. What can we do for one of these objects that you create to be sure that this one is going to be alive even though the program died? That this one can exist if I run the program again tomorrow, that I can recover something that I create yesterday. The solution? Store the object. Where? In the hard drive. By default, the objects live in the memory, in the RAM. And that is the reason because they die. In the memory, you kill the object, or the computer go off and everything is lost. If you put the object in your disk, if you store the object tomorrow or in a month, you can recover that object. And you can put that object again inside of your program. Storing objects, storing data, and have the possibility to recover that data, that object, is what we call persistency. The object is persistent. The object continues living even though the program that created that object is dead. One way to achieve that persistency in programming, in particular, one way to achieve persistency with Java is object serialization. Do you remember that we mentioned this for the scores? Do you remember that you can create a class and implement the serializable interface? And just like that, that object, that element can be serialized, which basically means that you can store that object and you can recover the object later. I need to show you an example of this. For now, the only thing that I need is to remember that you remember persistency, object serialization. We need to review that. Concurrency, multi-threading, the class thread, the interface runnable, and the timers. And we need to review that. Polymorphic behavior, creating parents for our classes. We already do that. We need to do more. Relationships, priority association, after that inheritance, and the last option, the diamonds, encapsulation and abstraction, a class, and be careful with what is private and what is public. Those are the key ideas for you to remember developing in object-oriented. Any questions so far? Nothing. Silence. Okay. Moving forward. I want to show you examples with serialization, and I want to show you examples with multi-threading, because you're going to need that in your next assignment. But before that, and just because you are working in a programming assignment, I want to be sure that we understand not only the principles for good design, but let's talk about the principles for coding, principles for programming, for the design: abstraction, encapsulation, relationship, concurrency, persistency. Okay, good things. Coding. You are doing programming and you are going to submit your assignment. We are going to read your source code. Principles in your code. Number one, these are some ideas for people that probably you know regarding what should be a good source code, what should be a good program. Number one, do you know that guy by any chance? Who is this person? Anyone? Thank you. The C++ guy. Okay. The definition for him is your code is good, elegant. I am sure that we all understand this quality. But what about this one? What does it mean that your source code is elegant? Have you read source code and can you identify, okay, this is more elegant than this one in terms of source code? Probably. Who is this guy? Almost. The UML guy. One of the guys for the UML. Simple and direct. Later, someone is going to change this to clean, simple and clean. And that is going to be the meaning of elegant, as someone mentioned in the chat. Your source code is elegant, it's a good source code, it's a clean source code, if it's simple and direct. You know what? In general, it was created by someone who cares. Let me be clear, guys. Your source code is not for the computer. For the computer is the code that you compile, the zeros and ones. Your source code is for you, for your team, for the people that is going to use, modify or extend, maintain that source code. You are creating source code for other people, not for the computer. For the computer is the compiled one. Your source code, the one that is for others, you need to be aware that others are going to be reading whatever you write. Your writing should be simple and direct. Your writing should be elegant. You're working in a programming project. Hopefully it's going to be like this. Your question right now is, can you be more specific about what is the meaning of that things? I am going to summarize this in 3 elements, 3 things that you can review in your source code. Number 1, your source code is easy to read. Easy to read. That summarized in, are you following the guidelines? The guidelines for the particular language that you're using? Did you know the guidelines for Java? For instance, do you know the correct names for a class, a method, or a variable? What are the rules for the name of a class in Java? What are the rules for the name of a method in Java? Or for the name of the variables? Did you know those rules? Are you following those rules in your assignment, for instance? Yes or no? And involve all of that. Upper cases, lower cases, denotation, and so on. Hopefully you know it. Hopefully you are following. We need to review examples, but follow the guidelines. How hard could it be? Second, the principle have an acronym, and it's basically your code should follow the KISS principle. The KISS principle, keep it simple. Keep it simple. I am doing a program, and one of the principles tell me keep your source code easy to read for others. Keep your solution simple. Do not try to make this something for you to showcase all your knowledge of several different things. The solution should be easy to understand for others. Hard to understand do not mean that you are smarter than the people that is reading. That is not the goal. Keep it simple. Again, how hard could it be? The last one, 3, dry. Do not repeat yourselves. Avoid this. Do not repeat. Repeat. Who is going to repeat things in a program? No one do that. You create a program and you repeat things. I mean, you add more source code than the source code that is needed. Some people do that. I am going to show you examples. The rule is do not repeat yourselves. Keep it simple and follow the guidelines. That's it. Principles for object-oriented programming. Something that you can do in your project. It should not be so hard. Let's review examples. Examples, and you can help me to grade some projects and tell me if your classmates are using or not Readability, KISS, and Drive. And hopefully you do not make the same mistakes. Number 1, 4 examples of variable declaration. I am creating those variables here. 1, 2, 3 variables, and I am creating a new class. Readability, yes or no? The names are good names, yes or no? For the class, for the variables. What do you think? Will you use these names in your projects? And hopefully the answer is no. I am going to start with this one. Guys, I know that if you are using a particular IDE, usually your IDE is going to tell you, or is going to create a class for you, and that class is going to have the main method, and the name of the class is going to be main. That is a decision that the IDE should need to make, right? The IDE need to put some name there. However, it is not mandatory to keep that name. You can change the name. If you are teaching something, or if you are doing some testing of a new thing, it is okay. Your class could be main or main window. When you are learning something, or you are testing something, when you are doing a prototype. If you're doing a prototype, and remember the definition of prototype is source code that you're going to put in the garbage. If you're doing a prototype, any name is fine. It's a prototype, it's garbage. If you are doing a project, it is your responsibility to think about good names for everything. And probably a class with the name main, or with the name window, or with the name main window is not exactly something that is the best option. But, well, a question mark there. It's not the best option, but under some particular circumstances, could be like, well, it's a prototype. You are just playing with new windows and you have several, and this is the main window. Big question mark. I do not recommend that name. However, the name of the variables. The name of the variables never do that. Not with Java. The rule with Java is you put words together. Java is a particular language in which it's better to have long names instead of something like this. Something like this is something that you did maybe with C++, and not with the current version, but with the versions 20 years ago, 40 years ago, in which the size for the IDs was some kind of limited. But today, we do not have that problem. Do not use these kind of things for the name of your variables. Moreover, if you're creating a variable and the variable type is this one, you do not need to put the type again here. You do not need to do int and the name of the variable. This is don't do this in your projects. What about the idea of simple? You need a good name there, but that is not the good one. Not for simplicity, not for being direct. This is a number. What that number is doing in your program? Is just a counter? Counter. It's a variable for the for loop. Int I. It's a coordinate. Int X or Y. Or whatever you are doing. Careful with the names. What do you think about the rectangles in red in this example? Could you use those names? Will you change something? Name of the class, the first letter, uppercase. So starting here, the G is uppercase. Even if I put the uppercase there, the name is correct. The name of the class should be a noun. So generate average value. That looks like the name of a method, is not the name of the class. Get average. You know what is the problem with get average? In Java, when you create a method and your method have the prefix getter on setter, get average, the assumption is that you have a variable with the name average. And get average is the access point to that variable. There is nothing wrong with the name. The problem is with the context. The rule in Java is get average, you have a variable average. And you know what? so far is not the case. We could be careful with that. Instead of get average, calculate average. Average. The rules for Java. This one, probably result could be better. Use the full word instead of use 3 letters. There is no reason to stop in 3 letters. Good. Okay. Do not repeat yourselves. What do you think about the rectangles in red? And why is that related with repeating yourselves? There is something wrong in the red rectangles, and if so, what? I agree with the chat. Guys, this is a constructor, right? How do you know that it's a constructor? There is no data type here, so it should be a constructor. There is no other way. Moreover, uppercase the first letter. The only method that have uppercase the first letter is the method that have the same name of the class, and that is the constructor. It's a constructor. What do you think about one constructor with only one method inside? What do you think about a method that have only one line? And that is the method. This is an example of repeating yourselves. This is an example of, I am calling the constructor to do something, and the only thing that the constructor do is to call another method to do the something that I should be doing here. Whatever you're going to have in this method should be the body for the constructor, no another method. This is repeating yourselves. This is creating another method to do what the constructor should do. This is having 2 methods for the initialization of the variables. Do not do this. Now, a different scenario is that you have a constructor calling 3, 4, 5, 7, 10 methods, because really the initialization is very, very complicated, and the constructor needs help, and the constructor is going to call for others to help. What I want to be sure that we understand and agree, this is not the case. Calling one method inside of a method is a big mistake. Don't do that. Dry. Okay, what do you think about this example? We are keeping things simple here. What is the problem? I could agree with you that we can create the variables in one line, but my concern goes beyond that. These labels. I have here 9 lines creating 9 labels. Later, I am going to need another 9 to do the new for the object. So in total, I am using almost 20 lines in my source code just to create some labels. That should be something easy. 20 lines. There is something that I can do to have less lines there. I could agree with the panels, yes, but well, I am not showing you the full source code, so use with this. There is something that we can do to move all of this to one line, for instance. Thank you. Guys, yeah, if you need one integer or two integers, it is okay to put integer 1, integer 2, or the same with the labels or whatever. If you have like this 9 to 10 labels and the same problem with 9 to 10 panels, just think about it. Here, probably 20 lines, and we can make them 2. It's exactly the same. It's a space for 10 labels and it's a space for 20 panels. I just put them together in an array. Moreover, I can think only in one name, the name for the array. That is my responsibility. The others are going to be the name 1, 0, 1, 2, 3, 4, 5, and so on. Instead of figuring out the names for several different instances individually. This particular case, I mean, one array, you have all the arrays together. If you really need kind of identify every single label because every single label is something particular, like the highest value, the lowest value, and so on, if every single one represents something, what you can do is to create constants for the index. Just think about my array of labels. It's not exactly the name that I would recommend, but something like that. Some constant in some particular class, and this one represents the one. You can define your constants. From my array of labels, give me the one with this one, or whatever. If you really want, instead of the number, to have a name that represents something, just create this constant, and that one is 1, or whatever. But again, when you're going to do the news, you can create a loop, and the loop 0 to 10 with only 1 new instead of 10 news. When you're going to define the variable outside, instead of these lines, 611 to 620, 1 line, the array, you can make this simple. It should be easy to read. Think about your reader. What do you prefer? 1 line in which you notice this, an array, or 10 lines, and I am reading label, 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 and I am just searching for the stop of the labels. It's not easy to read. Your brain can handle 7 elements at the same time. After 7 elements, your brain is like, whatever. You have 10 labels or 10 panels. 1 array is better. Yeah. Moreover, another comment connected with this. Guys, usually 90% of the time, when you are doing graphical user interfaces, panels, labels, and most of the widgets, you do not need to have them global. Think about it. Most of the widgets, the only place in which you need them is in the constructor. In the constructor is where you do the new. In the constructor is where you add those widgets to the screen. Never you need them again. Usually 90% of the time when you're creating a graphical user interface, your widgets, your panels, all this can be used a local variable in the constructor. Again, not always, 90% of the time. When you are doing a graphical user interface, ask yourselves, can I put this element inside of a method? Can I make this global instead of local? A rule, always, always, always. if you can put the variable local, it's better than have the variable global. The only reason for have a variable global if you need that variable to be used for more than one method. But if only one method, like a constructor, is using the variable, put the variable local. And in this particular software, all of this can be used local variables in the constructor for this class. But well, different story. Keep it simple. What do you think about that one? In the chat, position X and Y in which program? Well, in the Pacman, we have this X and Y global. There is, I mean, should be global because we have more than one method that use them. So they are global because we have, well, when you're doing a class like the Pacman, your only concern is if more than one method in the class are going to use those variables. We do not think about methods in other classes. We just think about, this is my class, this is my Pacman, I am the responsible to doing the Pacman, so X and Y are going to be used by more than one method inside of the class Pacman. And in particular for the Pacman, I think that is true just because we have this method up, down, left, right, and what they are doing is using those variables. Moreover, we have this getter, another class is going to use the getter to get access to the variables. So because the getter, because the up, down, left, right, those methods using the variable is global. More than one method using the variables. So the positions are global. Moreover, X and Y are attributes of the Pacman. X and Y are part of the features that define the Pacman. And remember, the global variables are equal to our attributes, and the attributes are the features for that particular class. So is a feature, is also needed in more than one method, should be global, the position of the Pacman. Good. Moving to this one. What do you think about this example here? And my question for you in the exam is, this is right? Do not repeat yourselves. Line 150, 151. Did you notice the problem? I have a method, and the method is add the component to the center panel. And the method receives a parameter. And the parameter is the center panel. Can we improve this? There is an error there or not? Can you agree with me that that solution should be A or B? Can you agree that you can have a method add to panel and therefore receive as a parameter the panel? So I am going to add something to whatever panel I receive as a parameter. That is clear, right? Add to the panel. Which one? The one that I am going to receive. In the panel that I receive as a parameter, I am going to add things. Add to center panel. If you are asking me to add to the center panel, you do not need to give me the center panel as a parameter. If the center panel, it should be a global variable. I should have access. center, center. Do not repeat yourselves. A or B, but not the C. Makes sense. Java documentation, part of the guidelines. Did you notice the problem with this according with the Java documentation, the Java doc? I don't know if you're familiar with Java doc. I am going to ask you to use Java doc in our next project. If you're not familiar, please read about it. I am going to share with you a link later, but just to let you know, in the Java doc, the description of the class or the description of the method, whatever, that is the first thing that you put above, not below. You put the description, and below the description, you can add versions and authors and other things. The description go first. Check the Java doc documentation also as part of the guidelines of Java. What do you think about this one? Do I need these comments here? Because I know that we learn in CSI110 that we can and should put comments in our programs. It's something that someone recommends you to do. Use the comments, whatever comments they are, multiple lines or single lines. But now you are moving forward to be engineers, not only programmers. So my question for you, a decision is, do we really need the 2 lines here, these 2 comments? Or probably that is something connected with this criteria. Okay, I fully agree with that statement, Ivan. Your code, your source code should not need comments. The best documentation for a source code is the source code itself. You should create source code that for any reader, just reading the source code is enough. Think about it. If I need to read the source code and also the comments, is twice the work for the reader. It's not a good idea. Someone that reads your code should be able to understand what is happening there. It is your responsibility to achieve that level. So these 2 is a bad idea. And it's a bad idea because read the definition. It's basically telling me something that I can read below. Now, let me be clear. It's a method. A complete different scenario is to use Java doc here. Tell me, what is the goal of the Java doc? Why the comments for the Java doc are different than the comments like these ones? Because I fully agree with your idea. The best source code is the code that is documented itself. However, Java doc is another thing. Guys, Java doc is because Java allows you to create an HTML web page for the API of your program. And as you mentioned in the chat, the Java doc, the source code. The idea is that you read one or the other and you get the information. Obviously, the source code is going to give you the details. The Java doc is for someone that is going to have access not to your source code, but to your .class or your jar file that is going to use your code as a library. And the Java doc, the comments that are going to go to the HTML page, those comments are going to explain that people what your code do, the inputs and the outputs. two different markets. The Java doc is to document your code as an API. They should explain the same that someone reading your code. Usually the people that read your Java docs are not going to read them inside of the code. They read that in a web page. So they could be the same, different sources. So Java doc could be okay, but this comment here, no. What do you think about this code here? Probably you're not familiar with the threads. If you are, you know what is happening here. But even if you're not familiar with threads, you can imagine what is happening in a method that is called wait for. Redundant. What is the redundant part? Do not repeat yourself, right? Two lines, exactly the same lines. Wait, I really need to check if something is closed several times. You need to check if something is closed. You really need to check this thing several times. What is the correct way to do that? This line run several times. In fact, why? Up to you, the line go inside of the loop or the line become the condition for the loop. But if that is the idea, you have loops. You do not put this and this down. Do not repeat yourselves. This comment. Or this method. And I can close with this one. What do you think about a method? In its components, do you think there is a problem with this method? It didn't fit in my slide, but big. Help me, how many lines in a method? There is a number that we can follow? One thing that I mentioned before, do not create method with one line. That is wrong. Now I can tell you, do not create method with 500 lines. That is also wrong. So keep the methods. That is my recommendation. There is not a magic number. Global idea, methods with 20 lines, around 20 lines are good. Remember the traversal for a tree, 3 lines, searching, sorting, 10, 20 lines. Those kind of methods, 20, good. Sometimes the methods are going to be big. Sometimes you need several different things in one method. 50, still okay. If you can print your method in 1 or 2 pages, it's okay. How many lines can you put in 1 or 2 pages? Depending on the font, but we are talking about something between 60, 120, 2 pages. The font that you want, 12 points, 14 points, 2 pages. If your method can be printed in 2 pages, still okay. 100, less than 100. If you reach the 100 point, that is critical because it's kind of your borderline. I do not want to mention magic numbers, but this 100 is the breaking point. Below, good. Obviously, there are scales of good. This is the best. When you move down more than 100, it's like from bad to crazy. Try to limit your methods to something around and below 100. More than that, it's going to be very, very hard to read, and therefore it is going to be very, very hard to do maintenance. So my example here with 500, but anyway, any question about the drive, the keys, and the guidelines? Can you apply them in your project, the one about programming? Hopefully, yes. Any question? Okay. Number 1, regarding your assignment, the tutoring. You do not need to implement the score or something regarding the tutoring in the assignment. You can do the tutoring with a timer if you want, but it is not mandatory. The only thing that I want, mandatory, moving the objects, the enemy alone, and moving the player with the keyword. Those 2 things mandatory. The tutoring and therefore the collision between the objects, that is optional. Second, all these rules, they are recommendations, very highly recommended for you to use them in your software developing. Good? Yeah, the menu for the best scores is also optional. I do not ask you for the scores for your assignment. That is going to be another thing. So not scores for the assignment, not mandatory. Good, guys? Okay, see you next lecture. Thank you.